Today we will see a type of reducers, concentric and eccentric, and what is the use of reducers. What is a reducer in piping system? Piping fittings. A reducer is a component in a piping systems that changes the pipe size from larger to smaller bore. A reducer allows for a change in the pipe size to meet a flow requirements or to adapt the existing piping. It means a reducer is a component in a piping system that changes the pipe size from a larger to smaller bore. Wherever your size of the pipe is bigger, okay, it wants to change the size, so we use a reducer. In a in a industry, it's called a reducer or expansion. Okay. How many types of pipe reducer? There are two types of reducers available. Is a concentric reducer and the eccentric reducer. The concentric one which resembles a cone. A concentric reducer is like a cone. An eccentric reducer it's look like something like a flat side, okay, and it comes to a joint to pipe sections on the same axis. The eccentric type has an edge which is parallel to that of the connecting pipe, which allows it to align with one side of the inlet. Most of the reducers are used in the pump station pipes, work to reduce the size of the suction pipe to match the size of the pump suction and flange. Reducer fittings used in a pump inlet pipe work are divided into two types, concentric and eccentric. Most probably, whatever the pump size you have, what is the line size you have, okay, so we need to reduce the size to and connect with the pump connection, both of the suction pipe and most probably in the discharge size. Now you can see here we have some of the cases like why we use eccentric reducer, flat side down and flat side up. So here we have some of the marks over here, that it means when you make a flat side down, so you becomes a air pocket, and you make a flat side up, so there will be no air pocket because this point will be always filled with the water or whatever the fluid is there, so it's filled, and this point there will be a no air pocket. If I use a flat side down, so here I have the conical point, and it here it will becomes a air pocket, and this water will always move like this way inside that, so this part will always remain empty, so that's why it becomes a air pocket. Most probably the case is depend upon like which fluids you have, so you can change with the flat side up and flat side down. Why eccentric reducer are preferred in the pump section? Concentric reducer can cause accumulation of vapor or air in upper pockets. The same page is like whenever you have, you can see here there is a empty area, okay, the point at the point there is a empty area and it's getting a air pocket, and here I've used a flat side up, the water is totally filled here, so there is a no air pocket is occurring over here. In case of the centrifugal pumps, if this vapor can cause pump cavitation, if it escape into the pump, it also increase the liquid velocity and pump suction, which is undesirable. If you take, if the pumps cavitation comes, so there will be a problem with the pump suction, and there will be no pressure you can get. You can see here what exactly use of eccentric reducer. If you have a same elevation of support, okay, here you can see there is a eccentric reducer is there, and here you have a concentric reducer, but you can see here you have a space, you got a gap between the steel and the pipe. That's why what is the exactly use of eccentric reducer, whenever you want to keep your steel at the same elevation, okay, if there is something like 3200, okay, toss, and your pipe is running like this way, okay, and then it's get reduced, so you cannot take a concentric reducer, because when the pipe will go straight, then your steel elevation should be matched with your BOP. BOP means bottom of pipe should be matched with your steel, because for this purpose, for this gap, I cannot raise my steel little bit up. It's better I have to keep the same elevation of a BOP. So most probably you can see in the pipe rack, or you have a sleeper. Okay, this is some kind of a sleeper and your line is running. So here you are getting a reducer, so you cannot use a concentric reducer. If you use a concentric reducer, what happen, this is your sleeper. Okay, this I make just example to get a more clear idea. So this is your line. If I take concentric reducer, so concentric reducer will becomes like this way and it will go above the sleeper. Okay, if I take eccentric reducer, okay, if I take eccentric reducer like this way, so I can take easily with the top of the sleeper. So that's why whenever you're using a eccentric reducer, so most probably it's come the flat side down when you are running into the pipe rack or something. Okay, this is your rack, so most probably your the pipe should be like this way, it look like this way. If you see front view or side view, okay, so this is your rack, one, one line, two line, three line. So your line should be go straight. That's why we use a eccentric reducer. Okay, and thing is, if your line is coming vertical down, okay, and there also, if you can see here, this is a, understand, this is a wall. Okay, this is a wall and you have given a support like this way. Okay, and there is a some lot of line are going down. Okay, and some of the line get reduced. This example, this line is getting a reduce. If I look this side view, okay, so this is a wall. Okay, and you have placed a support like this way. Okay, and your line come here and connecting a reducer. So what happen if you are making a reducer like this way, so again you are getting a gap between support and a pipe. So it's better here also you have to use flat side, not a down but flat side towards the steel, where you can place the support properly, or you can connect, and it means like your support elevation and pipe edge elevation, like this is a support and this is your pipe edge. So your edge and support should be matched equally. It should not be like to need a gap. That's why for the pipe rack, pipe sleepers, why we use a eccentric reducer. So this is the purpose of using a eccentric reducer. Well, when you are getting a size change and you are have a steel continuously, you have a 1 2 3 steel, so then only you have to use a eccentric reducer to maintain the elevation of the steel. Thank you for watching my video. Please click on a bell icon and subscribe my channel. Thank you.